DevOps Success at RavenDB with Oren Eini, Part 2.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
He remains dedicated and focused on architecture and best practices that promote quality software and zero-friction development. And now, part 2 of my interview with Oren Eini. Let's get on with the show. How have you designed your DevOps environment to identify when you're encountering that kind of tricky stuff?
Okay, so here's the issue. A lot of those things are stuff that you never think about. Try to imagine, how can I never imagined that we have to consider the fact that someone can literally steal my CPU away.
Yeah.
So in terms of the development process, RavenDB has, I think, 3 or 4 level of what we consider to be a standard test suites. So you have fast tests that typically take under a minute or two to run, and they're meant to just, did you break everything?
Roughly how many test cases are there?
Over just 1,000, 1,500, something like that.
Okay.
And the idea here is that, we really care about the performance of that. That's meant to give you quick feedback before you send the PR. Is this something that we need to worry about?
And for the listeners, PR means pull request?
Yeah, sorry. Then we have a slow test, which is I think 4,000 tests, something like that. Again, RavenDB has been around for over a decade by now. We got a lot of edge cases throughout this time. And that, depend on the system you're running on, can take about 30 minutes or so to run.
13 or 30?
30, 3-0.
Okay.
Yeah. Then we have a stress test. We have a test that try running in a cluster, interversion tests. I'm going to spin version 4.1 of RavenDB, see how it reacts in when I'm starting to use it with 4.2 version, a bunch of other stuff like that. And those would be the pass-fail for the build as a whole. Those tends to run every time that you submit a PR or make a change to a pull request. Those gets run on a nightly basis on a host of operating systems and configurations. For example, right now we are testing on Windows 64 and 32 bits, Linux 64 32-bit on x86. We're testing on ARM 32 bits. We're testing on macOS in 64 bits. We're testing under containers. We're trying to run the whole gamut of Express stuff.
And what's your build server of choice?
Jenkins. We have Jenkins and we have TeamCity, and they're being used for different things.
Okay.
Jenkins is, I think, to run the day-to-day stuff, and TeamCity to run the big integrations and stuff like that.
And source control is Git. You mentioned it's open source, so the listeners can literally download your product and investigate your source code.
Yeah. So it's github.com/ravendb/ravendb, and you can go and look at the code, and everything that we do there is in the open, including the stuff that I'm talking about. Let's do a monitoring of CPU credits. Let's monitor how we are dealing with I/O, stuff like that, integration with the how do I find seriously, it's ridiculous, but how much memory do I have is a really hard problem to answer.
Yeah.
And sometimes I feel like memory is a ridiculously complex story. For example, in Windows, if you ask for memory and you don't have one, if you don't have enough memory, you're going to get an error. I don't have enough memory. In Linux, if you ask for memory, you're always going to get memory back. Now, if you try to access that, the system may decide that, I don't have enough memory, and then it goes and kills the process. Any process, by the way, including you, or it may be that another process tried to do an allocation and then killed you.
Yeah.
So it's it's insane. We had to do a whole bunch of work around that. But coming back to the DevOps, the problem with unit tests, look, we have tests that spin up a 50 nodes cluster and try to see what happened when you introduce jitter to the network, and what happened when the underlying system is memory constrained, all sorts of stuff like that. But those are the things that we thought about. And it's really interesting. We had releases where people came to us and says, I'm trying to do X. And X was something that we never even thought that people will even try. I have a user who recently came to me and says, I have a problem. I'm migrating my servers from machine A to machine B. I have 1,500 databases on this server. And I'm running an error when I'm moving that to the next version. And the version they're using had a default limit of maximum number of 1024 databases on a single server, which you would expect would be enough, but apparently not. So we had to tell him how to increase that limit, and then we looked at one another and says, seriously? What? I know what scenario so many databases on the server is reasonable, but then you realize that, our users are doing that, so we have to deal with that. At some point, we decided that we needed something more than just unit test. So we're actually doing a whole pipeline of operations. One of them is benchmarking. So the process for release basically means that, all of the tests are passing. Now we're going to spend a week or two just hammering the system. So I have a set of machines that would be effectively just processing data as much as possible to make sure that we don't have any performance regressions, we don't have any load issues over time. So try to imagine that
after building, you fan out and do multiple deployments in different scenarios and platforms at once, so that you can execute these tests.
Now we don't run it on a nightly basis. Those tends to run after every sprint, and we do so after every sprint. We typically have a validation run. RavenDB the baseline on this machine is 10,000 writes per second. Okay, what happened if after in the current version, I think we have like 5 or 6 key scenarios that we are testing. Are they all within the expected difference? And what is the trend line that we have here? So again, if you're talking about hundreds of thousands of requests per second or something like that, it's typical that you have variance between them. But if you see, it's 1% down, 1% down, 1% down, we have to start doing that. If it's 1% down, 1% up, 0.5% down, 2% up, stuff like that, there's no trend line. I don't care about that.
Yeah.
So that's in terms of performance. The other thing that we do is try to do longevity tests. Now, longevity test is basically put the system under as much load as possible and just leave it over a weekend, over a week, and let's monitor. I mentioned performance, but performance also means resource utilization. So CPU, memory, amount of swap that being used, how much I/O are we consuming, all sorts of stuff like that. There also, but the interesting about those issues is that they caught us lots of interesting scenarios, but they didn't catch us some production issues. For example, I had a user who they ran a set of scenarios, and the scenario was, okay, create a new database, push some data into that, do some computation, and then just drop the entire database. Do that over and over and over again. And at some point they started, okay, let's run multiple scenarios with concurrent, create database, crunch the data, delete, create the database, crunch the data, delete. Now, after a month, they started seeing higher latency on requests. So the problem here is that everything is fine. Memory is okay. CPU, as long as do not make a request, everything is okay. But a request that used to take 6 milliseconds after restart now take 250 milliseconds. And when you restart, then everything comes back together. And it drives us crazy because we literally had to have a machine being hammered on that scenario for 3 weeks before we could reproduce the scenario. And the underlying issue was that we're using a thread local value. And the thread local value uses a linked list internally. Everything is fine so far. The issue here is what happens if you have a lot of threads that are being created and destroyed. So after a while, the total number of threads that ever exist in the system become very high. And then at that point, if you need to iterate over, okay, give me all of the values that I have from all of my threads, which is something that I need to do because I have a thread local value of how much memory was allocated by this thread, then suddenly I'm looking at a list that may contain 200,000 items.
The Azure DevOps Podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
So you have so many test scenarios and so many of these cases. You probably have more things to test for than the average application developer, I imagine, with this type of product. But you
I think so.
You also employ several types of static analysis. At least it appears that way from the Git repository. Can you talk a little bit about your thought process on the value you're getting from static analysis?
Yeah. So we have a whole bunch. Well, I don't know a whole bunch, but we have like 5 or 6 different Rosin analyzers that, for example, if you're using async and in a library, you always has to use configure wait false on everything. Now, this is one of those things that it's almost invisible. And if you look at the code review, you don't necessarily see that. You don't see the missing parts. Oh, I passed in a task and I'm actually waiting on that somewhere down the line, but I'm not seeing if I did it or not. So we have analyzers that would alert you if you're missing configure wait false. We have analyzers for all sorts of known suspects behavior. I would actually have to, the configure wait, I remember being
So
pretty
you've
important.
gone through, you just use the default Roslyn analyzers. You've gone and created a custom set of rules for the product.
Yeah, for example, we used to have an analyzer that looked at how you're doing logs.
Yep.
So, okay, this is a common example.
Well, for the listeners, why are you using static analysis just even as a method? What does it buy you?
I wouldn't be, it saves me, it's okay. So there are certain tasks that I set out a rule that this is how I want the code base to be. The configure wait is a great example of that. Another example is that login. When we are logging, there is we want to provide rich logs with a lot of information, but they are horrendously expensive to generate. So we only want to generate logs when necessary. That means that, and for performance reasons, that means that we have to wrap every log statement with an if log is enabled to this level, I'll build a log statement, then send it, and then actually send it to the log. Now, when I'm looking at a piece of code, especially if I'm looking at a major feature, I'm looking at the core concept here. Having a human sit and say, okay, I see that you're returning a task. Have you used configure wait? I see that you're doing a log. You're missing if level enable, stuff like that. There are certain things that don't require any thinking, and those are the sorts of things that you want to have a machine do. We used to have an analyzer for, and I think we still have that one, for a particular known link statements, link expression that are known to cause performance problems, a bunch of other stuff like that. We also do, I don't know if it's static analysis, but we have tests that test the behavior of the system, that test the structure of the system, not the behavior of the system. For example, RavenDB has multiple levels of route with different access. So you may have a certain operation that only admin can do. We have a rule, any operation that has admin permissions must be in the namespace admin/. Now, we have a unit test that goes over that and says, okay, everything that has admin /init must be with admin privileges, and everything that has admin privileges has to have a /admin init. And that ensures that we get the right structures. We have a lot of stuff like that. We have, here's another good example. We have RavenDB comes with a studio, with a full-blown GUI interface to manage it. There are a lot of tasks and things that we expose to the studio. We have unit tests that effectively just list, here are the things that the studio know how to handle. Now, if you add, for example, I have a backup, RavenDB has backups and it has multiple backup destinations. Now, if I add a new backup destinations, I need to go and update the unit test about what are the things that I already added to the studio. For example, SFTP and FTPS are two totally different ways to do secured FTP.
Yeah.
Now, if I'm supporting one and I added support for the other, it's trivial for me to do this operation. But it's also trivial for me that I would never do the studio part. I have no idea how the UI works. So that serves as a check to make sure that we go and actually implement other pieces of the pie. Another thing that we did that was really good, we spent a sprint or two just writing different scenarios. I went to
different test scenarios.
Not a test, just user scenarios, explicitly not about testing.
Okay.
So, I want you to write a casino application. Now, with no UI, with some set of randomly generated behavior, and I want the other guy, I want you to write me a Little League Soccer website. And the interesting about this, those are not meant to be benchmarks. Those are not meant to stress you out. We actually we spin up the cluster, and we start running through those scenarios, and we will run them at random intervals with random length concurrently, almost like that, all of them trying to reproduce I'm starting an application, I'm letting it run, and then I'm starting a backup, and then I'm going to lunch.
Right.
At the same time, 9 a.m., everyone comes in, and I'm trying to have to deal with 9 database coming at the same times. Each one of them is 100 gigabyte. What do you do then? Now, the problem here is that I'm not smart enough to think about all of those scenarios, but all of those various things. But by being able to build all of those scenarios and then just randomly permutate through them, gave us a lot of value. For example, we had a case where a user would set up a database, would set up a backup to happen every hour, and one of the permutation created 100 invocation of the same scenario. So now we have 100 databases, all of them creating the same backup strategy. So on the hour, I had 100 databases that all try to start backing themselves up. And that killed the system, because now I have all of them are fighting for every bit of resource on the system. I/O, memory, CPU, everything.
And it's natural to, back up at midnight or back up at 3 a.m.
Exactly.
People just tend to pick the top of the hour, and I can see that.
And especially if you're doing things, and the issue here, try to imagine what happens when, I'm doing some sort of automatic setup, create a database, create a backup process, and for every one of my customers, I'm going to create a separate database. It starts going great. Now I have 20 users, and at the top of the hours, the entire system goes down.
Right.
And you start seeing those sort of behaviors. And then we run that on VMs, we run it on bare metal hardware, we run that on cloud instances. We actually found the CPU credits issue because I remember I have a team that is responsible for performance and monitoring. And the team that comes in and says, we have a problem on the cloud. RavenDB keeps killing the machine. Because what happened, I think that, let's say that it happened with the backups issue. You have lots of backups running through all of the CPU, and now you have no spare CPU capacity left, and every time that you earn new CPU credits, they go into the backup processes that are there running. If you're trying to log into the machine, it's not responding. There is no CPU cycle for that to respond. If you go to the cloud portal and look, what is the CPU utilization? It's zero. It's zero because you are being throttled. But you don't see that. You don't see anything. And that was actually something that was, how did we mess up the machine so badly that it requires a reboot for us to even understand what's going on?
Yeah.
And you find a lot of stuff by trying in different environments, trying to do. At some point, we had what I call the Monkey Week. And the Monkey Week was basically, I want you to take RavenDB, and we basically said, you worked on this feature. Therefore, what is the feature that you're least familiar with? I want you to go and try to do the worst possible job on a feature that you're not familiar with, you don't know how it works, and try to be a monkey. Just do stuff randomly, see what happens.
Yeah, load the whole collection, modify one property, just hit save.
And for example, I had a guy who put everything on the shared disk, the network disk. And because of that, we realized that under certain cases, the CIF file system, which is the common internet file system, which is used for file sharing, doesn't support certain operations. I had another guy who tried running RavenDB with no swap, and that's how we realized that RavenDB will actually, if you run RavenDB with no swap, it will work because RavenDB will actually try to allocate on memory map files because we're trying to work without the out-of-memory killer in Linux and a whole bunch of other stuff like that. Literally, who was the monkey who set up the system and got us into this place? And
it happens.
Yeah. The problem that I actually have, I tried several times to get a professional testers and get them to go and look at the system and try to break it. And it's really hard because typically if you go to a company, I want you to test my system, you give them a spec and they verify that the system behaves according to the spec. I already know that it mostly does that. And I don't care about, you have misaligned.
You need exploratory testing.
And I need exploratory testings that are done maliciously.
Yeah.
What happened if you...
What am I missing?
Yeah. What are the things that I don't think about? And the problem is that it takes quite a lot of time to get enough knowledge into the system before you understand how it works. Then again, I got people in my team that are bug magnets. Like I have a guy, and you tell him, "Can you go fix a typo in this page?" And he come back, "Okay, I figure out that if you click this button 3 times in succession, then we are leaking memory."
He's just curious.
I know
he wants to understand everything.
It's just how did you get that? And that's not possible. And then you realize, okay, it's not a bug. It's meant to be, but we only clean up this memory after too long. And if you click enough times, and why were you clicking that 300 times anyway? Those sorts of things. And so some people have talents for finding bugs. And that's amazing. I'm
awesome. Well, you got that's so much. That's some great detail about how you guys do DevOps and the focus on static analysis you have, and after building, you're running multiple platform test automation. A huge focus on test automation. Before we wrap up, I just want to for any listeners who maybe have never used a document database before, and they just, you know what, I use SQL Server, and I figure out how to use SQL Server regardless of the scenario, and I'm always using SQL Server. What are the corollaries in RavenDB, and when should they think if certain forces are at play, maybe I should look at RavenDB? Like they're used to tables and stored procedures, and then an ORM on top of it. How do the concepts map with RavenDB?
So I mentioned earlier that I built RavenDB from the point of view of an ORM. So it's not supposed to be an ORM against some data store. It's supposed to reflect how you actually been in your system, and a lot of that depends on your modeling strategy. If you're using something like DDD with aggregates, then things are going to become very easy. But
And DDD stands for Domain Driven Design.
Yes, sorry.
No,
Yeah,
I'm the acronym police.
Yeah. Now, the real problem here is that with a relational database, you're forced into rigid schema, and you're forced to spread your data around multiple tables. The issue here is that in many cases, the level of complexity in our systems today means that you have to have objects that are composed of so much data, so much spread, that trying to load a single object can be extremely expensive. Going back to the orders example, which is trivial. I have orders and order lines. Order lines goes to products. So far so good. But I also have discounts, sales and offers on the order. I paid with a credit card and cash and coupons. I also have to apply loyalty points. There might be some, and also all of the things that the user is aware of. I might also have to offer coupons. Oh, you bought this and that. Let me offer you stuff for the next sales. And then there are stuff that you don't see. Oh, based on this, what are the recommendations that I'm going to give you next time? And suddenly you look at the model that you have for an order, and it's huge. And if you try to throw that into a relational database, that's going to sit on 30, 40 tables. And now you're faced with, okay, let me show you an order. Let me print you the receipt for the order, and you're going all the way back to select N plus one or being very careful about how you build things. With RavenDB, the impedance mismatch between how you think about your model and how the data is stored is much smaller. Other important features that makes a whole lot of difference. RavenDB is transactional, which means that you don't have to give up transactions. But when you start looking at how RavenDB does things, right now, if you want to deploy an application using a relational database, you typically have to go through at least some level of a spike in the system, see, oh, am I using the appropriate queries? Am I using the right indexes? I need to have a week with the DBA just to prove the system. With RavenDB, if you make a query to the system, the query optimizer is going to figure out what is the most optimal way to execute the query, which is exactly the same as in a relational database. The difference is what happens when I don't have an optimal way of doing that. If I'm asking you, oh, give me users by name, and you don't have an index or name, then a relational database would go and says, okay, let me go through all of the records. RavenDB would say, oh, if I'm going to have to go over all of the records, I might as well go ahead and create an index for that. And the next time that you query on a username, you're going to hit the index. Now, there is a whole bunch of other stuff there that are meant to optimize and handle that. But the key here is that RavenDB is actually going to take into account not just a single query, but your entire history of operation against the database as it build your own indexing strategy, self-configuration, what resource should go where, and all sorts of stuff like that. That means that in terms of development time, in terms of runtime in production, a lot of that goes away. A lot of the complexity is gone. If you're building a new system, and you're using a relational database, literally the first thing that you're going to have to do is create a schema. And if you realize that, oh, I now need to make a change, now you have to create some sort of migration.
Yeah. So how do you migrate your data structure? How does that concept come into play with RavenDB?
From collection update, and then you get effectively a JavaScript function that you can apply over all of the documents that match a query. And it modifies the document. And now you have the ability to run really interesting transformations. But at the same time, in many cases, you don't even need to do that. If you introduce a new field to the database, it's just going to work. If you remove a field from your model, you don't have to do anything. a lot of you need to do active steps to handle data migration very, very rarely. But that means that you get a model, especially during development, that is much cheaper to evolve. You don't need to, because if you think about it, you build the schema as the first thing that you do and in the project, which is the exact time that you know least about what you're actually going to do. And then you have to, effectively, you pour the foundation in concrete, and you can move the foundation. It's just going to be really, really awkward.
So is there a migrations process or tool for when you need to transform from time to time as part of your deployment?
Yes.
Okay. And what about integrating with other tools for people who only use SQL Server? What's their experience going to be like when they say, okay, I've got SQL Management Studio, I have a data warehouse over here, and I'm used to being able to write a SSIS package to kind of do a dump. What's their experience?
I don't believe that anyone wants to write an SSIS package, ever.
No, you have to. Yeah, exactly. You don't want to.
But no, that's key. Because with RavenDB, you can go to RavenDB and tell it, okay, I have the data in relational form, in a document form in this place, and I want the data to be in relational form on that place. And you need to, it's funny, you need to give RavenDB a JavaScript, a JavaScript script that will translate between the document form into the relational form, and then the connection string of the database that you want, and then RavenDB will be in charge of pushing all of this data. Furthermore, instead of doing something that happens only as a job every night, something like that, RavenDB is able to run it on a continuous basis. So you always get the data pushed outward. It's very common.
Okay, so you create the JavaScript mapping between the collections and a SQL Server schema, and then Raven essentially just does automatic data shipping? On the fly immediately
with high availability. If the database destination is down, you don't lose anything. When it's up, RavenDB will send everything that it missed. If you run in a cluster and the node that is sending the data died, it's going to transparently move to another node and continue from where it left off. I think that SSIS, I work with that a lot, and it gave me the shakes, it gave me nightmares, because it was so how to work with, how to debug, how to deploy, how to version. And one of the things that I set up with RavenDB is I don't want to be in the place where I'm tearing my hair out trying to figure out what's going on, or trying to do something that is supposed to be simple. If it's supposed to be simple, let's keep it simple. Let's give the user the capability of doing that, and let's just get out of the way. There are a lot of other things that are important. I mentioned performance, and that is actually composed of several things. You're typically going to have better performance because RavenDB is going to adapt to your system on the fly. The model is different, so you don't have to crawl to have the database to get the data that you want. The database itself is pretty fast, but you're also going to see things like, I'm deploying to cluster, and this is trivial to deploy a cluster, and now I get high availability for free. And I'm sure you had to set up a cluster SQL Server. But before you set up a cluster SQL Server, you fast, you get
There's
ready.
A lot to it.
Yeah. And with RavenDB, I do that. Yeah, I actually have a demo of me doing that with explanation. It took me 10 minutes. With all of the relevant security, with all of that deployment, and it just works. And now I made it work. All of the clients know how to handle that. Transparent failover. It works. Look, it's funny. The point of RavenDB is to be boring.
Yeah, right. Just make it work.
Yeah.
Well, this is fascinating information on how you've done your DevOps environment for this particular product, which has some unique complexities over application development. For the listeners who maybe want to learn more, what resources would would you point them to for them to look up?
You can go to RavenDB.net. There is a Learn section there. I have a full-blown book available there. You can go on the website, read it for free. It goes over all of the details. There are multiple boot camps, videos, all much of other stuff that you can learn about that. I'm also doing regular webinars exploring different options and different way of thinking. That's it.
Okay, awesome. Wow. Well, this is a great interview and a great show. I really appreciate you spending the time with me, Oren, and diving through it. Thank you.
Thank you very much.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.